Welcome to Inside Startup Investing, the only podcast where you can invest in every guest. On this episode, I will be speaking with the CEO of Avadain, Bradley Larschan. As a reminder, Avadain is raising on net capital, regardless of whether or not you are accredited, with a minimum investment of $250 until August 29th, 2026. Fortunately, the team has hit their max goal of $5 million. Unfortunately for you, you may not be able to get in on this round. But it's worth indicating interest should some of those dollars fall through prior to their close date. I've known Bradley for several years now, and have to say, his love, passion, and energy for what he does never wanes, which for many may be hard because inherently what Avadain does is kind of boring. If you remember back to the number 2 pencils you used back in elementary school, the main material in that pencil was graphite. Amazingly, if you distill down graphite, you get another material altogether called graphene. And graphene is widely understood to be one of the strongest, most durable materials in the world. Using tiny trace amounts of graphene as an additive to other strong materials like carbon fiber, plane parts, or bike parts can completely change the weight profile and strength profile of a plane or a bike. Essentially, graphene is a way lighter and stronger material than carbon fiber, and pretty much any other advanced material out there. This can be an absolute game changer for all sorts of applications and products, but taking the theoretical benefits of graphene and putting that into mass production is a whole different story. And that is where Avadain is creating its competitive advantage and moat as a business. For a decade, this team of scientists have developed the processes and capabilities to bring this material science to fruition for real commercial success, and is potentially months away from ramping up with its first large commercial partner. This team has been methodical and consistent in their approach, and it seems as though they continue to take the necessary steps to bring this incredibly valuable new material to the world. While there is still risk in this one, Brad and his team have shown an unwavering commitment to bringing this technology to market, and I am excited to keep my eye on this one. So with that, let's get on to the show, and welcome Brad. You know, for those who don't know you, Brad, I know you're a returning guest here and always love seeing you. Tell us a little bit about yourself and what Avadain is all about.
Sure. Let's do Avadain first. Avadain is a company that's creating a technical pathway to manufacture at scale the most disruptive material that's ever been discovered. It's called graphene. And graphene is a single atomic layer of graphite. And that 6-sided carbon, when it's in graphite, is perfect for pencil lead, right? One of the most boring substances you could imagine. But if you take it down to the single atomic layer, it takes on absolutely fantastic qualities, Chris. It becomes the strongest material ever discovered. It's 200 times stronger than steel. It's the best known electrical conductor. It's also the best known thermal conductor. It operates in an entirely different set of physics. And so what we're trying to do is build on the work that the Fraunhofer Institute for Applied Solid-State Physics discovered in 2016. We funded that work. And they devised a way to create the highest quality, large, thin, defect-free graphene. And then that material gets used as an additive to transform thousands of products and make them stronger, lighter, more conductive, more durable. And so that's what we're doing. My background, of course, is as an international lawyer. So absolutely nothing to do with what we're doing here. But I've been working on technology commercialization for a long time and on this graphene project since 2016.
Material science, you know, the innovations that have come from it affect all the things we use every day, and you don't even think about it. And yet it can be so large, right? When you think about graphene and its abilities and its strengths as a material, talk about some of the end use cases you see for it, and where are we in terms of taking this from hypothetical Wow, this is such a powerful, amazing material to actual commercial application.
Sure. Well, there are literally thousands of end-use applications, so I'll just give you a few illustrative ones, and I'm happy to talk about any more that you would like. Let's talk about a commercial aircraft's body. The commercial aircraft is largely these days made out of a composite material, and that composite material has a high degree of carbon fiber in it, and that's great. It's strong, it's durable, it beats the heck out of heavy metals, but it's still heavy. So by adding a little bit of graphene to that, you can amplify the performance of the existing carbon fiber so that you can reduce 50% of the material needed. That means you can lightweight the plane. So what does that translate into? Well, it means aircraft that are more fuel efficient, but it also means that we can make drones that can go further and loiter longer over the target that they're looking at. So that's one of the really cool applications we're thinking about. Another application is that researchers around the world have proven that graphene at this single atomic layer level can augment critical minerals. Right now, there's a big push by the U.S. government to augment critical minerals and build production here in the United States because we're heavily reliant upon other nations and in particular China. Well, graphene can replace 10 critical minerals for the performance that's being used, but at the same time, it can also augment other critical minerals so that you can use much, much less of them and obtain the same performance. So there's performance amplification. Some of the other many uses of graphene that we can think of are in building materials. We wouldn't use our material because it has too many other high value uses. But some competitor companies making nanoparticles and other graphene materials are finding that they can increase the strength of cement and asphalt so that you can build roads that don't develop potholes to anywhere near the degree. So it's really a very revolutionary and disruptive type of material. So we have built a full-scale reactor, and we are now building a pilot plant around that reactor. And we make the graphene in the reactor currently by hand, which is great because we learn something every time we do a run, and there's no beating that. But in order to produce it at scale, we have to put it into an automated process. So we're building the first pilot plant. That hopefully will be my Christmas present this year. That will have everything from the graphite that goes into it to the graphene that comes out at the other end, and it automates the process. Once that is demonstrated, then our first licensee, Harcross Chemicals, is going to order their first full-scale plant, and they've indicated they'd like to order 10 full-scale plants by 2030.
What does 10 full-scale plants mean?
Well, it means that this is as much a logistics question as anything else. Think of a 3-pound lump of graphite in a 40-foot container, right? You would be hard to find it, right? Because it's just such a little amount of graphite. But if you put that through our process and separated the atomic layers, it would more than fill the entire container with graphene. That's because it's still 3 kilograms or 3 pounds, whichever. But you've freed it from the atomic forces that bind the graphite together and freed them so they are individually much larger in their natural state. And so you want to have production plants for graphene close to where it's going to be used. And that makes it more efficient because otherwise you're shipping air. And so that doesn't make any sense. So we have a modular-based strategy in order to create the production near where the end use is. And the end use is both for military applications, but much, much more for civilian applications, across 45 industries as an additive material.
When you talk about that first chemical company that you're in discussions with, what type of stuff do they do? What excites them? What are the applications they want to utilize it for?
So, Harcross Chemicals is a 109-year-old employee-owned chemical company, and they're really at the cutting edge of technology. That's how they've made it. People like Dow, DuPont, the Goliaths, BASF, the Goliaths of the industries, are not such rapid innovators that they apply the mass to certain industries in order to control it. So Harcross has to be nimble and innovative. And so they're always looking at creating new things and new products that they want to do the distribution for. So that's it. I don't really think I should talk about what their strategic plan is for it. They can address that in good time.
When you think about the commercialization strategy, it makes sense. You have a great customer kind of like right at the forefront for you all to work with as you move into the commercialization phase. But because it has so many end applications, like what is the strategic go-to-market strategy so that you don't kind of get lost in the sauce? You're like, hey, these are the beachheads we want to go after.
Right. So Avadain has no intention of ever manufacturing graphene itself. We want to work with established chemical companies and advanced materials manufacturers. And so each one will have a market niche. The Graphene Council, which is now the Advanced Carbons Council, estimated that the demand for graphene, our type of graphene, will be somewhere between 30,000 and 90,000 metric tons, in the next 5 to 10 years. So we have this steep path to pursue in order to get market penetration. So each of the companies that we will license to produce that material already has existing customers that they will then provide that material to. We have a 10% royalty. That means they keep 90%, but they have to absorb the CapEx. So these are companies that already operate plants all over the country, and they will build graphene manufacturing into existing facilities to serve their existing customers' needs. That's the immediate go-to-market strategy.
It makes a lot of sense. What does it take to get a large chemical manufacturer or applied material science company to work with someone like Graphene? What do you have to prove to them? It sounds like technology-wise or material-wise, this has tremendous benefits. So what do you have to prove to get them to become a customer?
Yeah, that's a great question. So about graphene, I don't think we have to prove anything because it won the Nobel Prize in Physics in 2010. So really people have been working since then on figuring out how to manufacture high-quality graphene at scale. There are more than 400 lower-quality graphene companies out there already producing suboptimal graphene materials that go into a lot of socially beneficial projects, building roads, you name it, they can do that. And that's great, it all works. What most of the customers, our target customers, who would be the licensees, are waiting for is to see a first mover do it so that they prove that it can be done and the bugs have been worked out, and then they will do it. And that's if you want to get into the exit strategy at some point, we can talk about that because it ties right into that.
So is the differentiator thing that sets you apart from like graphene producers is the technology to be able to take that 3 pounds and turn it into whatever, expanding over 40 feet worth of material where you can kind of split it apart so that it can be augmented and put into other materials?
No, the thing that really differentiates Avadain from everyone else's technology is that we're able to combine the 3 factors that are necessary to have the ideal form of graphene. It has to have large surface area, it has to be atomically thin, 5 or fewer atomic layers, and it has to have no defects. And so many of the processes use oxygen in the process of separating graphite and the carbon and oxygen bond producing oxide. So we have graphene oxide. China, for example, controls 70% of the world's production of graphene oxide, and they integrate that material into practically everything on an industrial basis. It's vertically integrated into their defense industrial base. But it has about 10% of the quality of the ideal form of graphene, and that's because the oxygen gets in the way and creates brittleness and it blocks the conductivity of the material. There are many companies that can make atomically thick material that they call graphene, which really qualifies as graphite. And those are called platelets, nanoplatelets. And so lots of companies make that because they haven't figured out how to get it down to 5 or fewer atomic layers. And then there are companies that make the material that has a lot of defects. And, that's done. So we have more than 400 companies out there trying to make graphene because of the work done by Fraunhofer and Southwest Research Institute since 2016. Our process does it to create the large, thin, defect-free flakes.
Which I imagine makes it far easier to put it into all of these other materials, whether it be carbon fiber or whatever else.
Exactly, and we only need a trace amount. One of the really brilliant things naturally about graphene is that you want to have the least amount possible that achieves the performance you want. So like 0.01% to 0.05% loading of our graphene can really transform a product and make it, perform much better with the addition of the graphene.
So something like a carbon fiber bicycle frame, you could put it into that carbon fiber and dramatically increase the strength of that carbon fiber just by having a trace amount in there.
Or into a carbon fiber jet, the 787, right? It's still heavy, and so what you would do is you would integrate the carbon fiber in the production phase of the carbon fiber with a little bit of graphene to use up to 30% less of the carbon fiber, making that plane lighter, which would make it more fuel efficient, and it would still be stronger.
I feel as though, having spoken with many founders in kind of the industrial space, when it comes to industrial things, industrial applications, development of an airplane or whatever it may be, there's a tremendous amount of risk averseness and a lack of willingness to change because of that risk averseness oftentimes, right? Is that your experience, and how do you overcome that?
Yep, absolutely. And I'm with you. We use that as an example, but a practical application in the aerospace area would be drones. They're unmanned, so the time to adoption is real time rather than years and years and years of testing. The United States is going to be buying hundreds of thousands of drones next year, so we can help make those drones lighter, stronger, and they can be, to some great degree, impervious to electromagnetic interference, so that blocking and jamming of the drone can't take place because the graphene acts as a shield to those electromagnetic signals. Really what it does is it converts those electromagnetic signals into heat, trace amounts of heat. So when the signal, whether it be radar or jamming, hits the graphene, it naturally becomes heat. That's just how the physics of graphene work. So the answer to your question is, we are not going after the building rocket ships, building 787s. We're going after drones and different building materials and different materials that we use in everyday life. Automobiles for energy storage, for different things that don't require that ultra high degree of safety.
Because you're kind of just licensing the technology rather than being the manufacturer of, I imagine that means that kind of your upfront investment in terms of creating factories and things like that is dramatically lower, if nil.
Exactly. It's a very capital light business model. Industry generally, chemical companies, advanced materials companies, have to have graphene. Graphene is going to be the material of our age, and it will be something they can't ignore. So, by 2030, they will all be using graphene. That's my prediction, okay? So we saw that clearly. So instead of having hundreds of competitors, now we have hundreds of partners, right? Because if Dow wants to produce graphene for their existing customer base, they can license it from us. And we have a very modest licensing fee. and they can then produce it and give it to their customers, right? So we can be partners in that. Same thing with DuPont or other companies. And so that allows us to have a capital light model that can return a really great profit to our investors, but still leaves 90% of the revenue with our licensee.
In terms of where you're at, you're getting very close to kind of the commercialization phase and being in the hands of one of your first really large customers. What risks, as an outsider who doesn't know a ton about, chemical companies and material companies, what are the risks we're not thinking about that could still prevent you from getting there?
On the increase the scaling of the production capacity, I think once we have, hopefully by Christmas, my Christmas present is my pilot plant, my first production plant. So everybody, I want you to write to our manufacturer, Brad's Christmas present, right? Is that we don't see any technical obstacle. It's just engineering at this point. All the scientific challenges are solved. Once that's true, then we should be able to upscale to production level units. That should be true. Then the application of the graphene into each product category, that requires investigation, right? Because what you want to do is use the least amount of graphene possible. Because remember, graphene comes from graphite, and graphene's sole desire in this earth is to become graphite again. So you want to have the tiniest amount to amplify the performance of the materials you already use. If you put too much graphene in again, it's going to behave more like graphite than graphene. So you don't get that unbelievable amplification of qualities.
That makes a lot of sense. In terms of the current capital raise, where are those dollars being applied? Where does that help you get to?
Well, I'm happy to report to you that the capital raise ended. We just ended it on Friday. We hit the $5 million mark.
It was incredibly fast.
Yeah, we did it in, I think it was 39 days.
Wow.
And so, we're so fortunate to have, loyal investors who turned out, plus a whole bunch of new investors. I had one new investor who put in $858,000. New investor. So it was absolutely just so, so warming to us. It just made the whole team feel good that people were paying attention. So with the dollars raised, we are going to finish the pilot plant. After that, we should have $6.5–7 million cash on hand. Then Harcross Chemicals will give the no-go on building the first 1 or 2 full-scale plants, looking to ramp up to 10 by 2030. That puts us into a cash flow positive position. We're also pursuing additional federal grants and a couple of federal contracts. So hopefully the turning point for the business, where it's proverbially all downhill from there, is once the pilot plant is operational.
For investors who are thinking about coming in and they want to understand kind of what does the exit plan look like? How do I make a return? What can you tell us on that front?
Sure. Our model hasn't changed since the very beginning. We want to have $200 million in annual recurring revenue, ARR. That comes principally from royalties from licensing. And at that point, we're open to an acquisition. We believe we should get somewhere between a 5 or 7x to a 15x, because we're really at the beginning of a hockey stick growth. With $200 million in annual recurring revenue, that means we have 10 production lines out there. To meet the forecasted demand by the Graphene Council of 30,000 to 90,000 metric tons, we would need thousands of production lines. So we need a company to come in who will say, yep, great, you de-risked it, you demonstrated it works. Now it's time for us with an unlimited balance sheet to come over, invest the capital to grow the business and make it into what it can be, looking at a 100 billion target or something like that.
For investors who are on the line, they're not there yet, I want to give you the last word. What do you want them to know?
Well, I think the most important thing is that new materials can be very exciting. It's not overnight. As I say, we've been working on it for 10 years. We're getting close to the end right now, and we feel that once the pilot plant is done, it's there. But materials are an essential part of life, and in our modern society, advanced manufacturing rests upon new materials. Every industrial age has started with a new material, and we think graphene is that new material. So just stay tuned. I'm told by DNA that we've raised now the second most amount of money in crowdfunding of any company since 2016. So I don't know if we'll be doing another crowdfunding round, but we could, and we'll just have to see how it goes.
If you like what you heard on the show today, you can check them out on netcapital.com and keep an eye on them should an allocation open up in the coming weeks, starting at just $250. And of course, if you want to learn more about this company, you can go to kingscrowd.com and search Avadain. For more episodes like these, click the like or subscribe button to hear more amazing interviews with founders and CEOs just like Bradley. Thanks and have a wonderful day.